Okay, I think we'll go ahead and get started. There are likely to be people trickling in. If they're like I am, if I didn't have to be here speaking, I would take my time getting to the next session after lunch. Feeling a little bit sluggish, but anyway, they'll come in and we'll already be in the presentation. My name is Daniel Hardman. Hopefully if you read about this session, you might know a little bit about my background. I work with Hyperledger Indy project mostly. I'm a maintainer there. And I also work for, so I have a day job with Evernym and then a side gig where I work on the technical governance board of the Sovereign Foundation, which is closely connected to the Indy project. Anyway, today I'm going to talk about some concepts that have been marinating in my mind and in the minds of some people that I work with for quite a while. Not all these ideas are originally mine. I want to give credit where credit is due. Lots of other smart people have been talking and thinking about this as well. I'm just a spokesman for a lot of other people. And hopefully the title intrigued you a little bit. Microledgers and edge chains. I'm going to demystify that, and when you walk away, I hope you're going to think of this as not so much a super technical session that you've been to, but instead a session that kind of has some intriguing ideas for you to think about later in whatever you're doing. So I'd like to start by taking you on a little bit of a personal journey. I started working in blockchain 2.5 years ago, and when I first became I guess, aware of the basic concepts of how blockchain worked and so forth, I became really excited about how blockchain had solved a bunch of problems and I was going to go conquer the world with all this new technology, and it was awesome. And that was, I lasted in that phase of my acquaintance with blockchain for, I don't know, several months. But I started to encounter practical problems with some of the blockchain stuff I was doing. And I hope as I describe the rest of this arc, you'll smile a little bit to yourselves and say, yeah, I've kind of been through this same thing. So, you know, after my, in a way this is kind of like the Gartner hype cycle, you know, there's the spike of excitement and then the trough of disillusionment. So I kind of went through learning about some of the performance and scaling issues that we had to deal with and some of the complexity. And then I started to realize that putting data on the blockchain had certain repercussions that I didn't always want to deal with, and that there needed to be some very careful thought about how we encrypted data. And then I realized encrypting it wasn't enough, it just plain shouldn't be there at all. And so hopefully you guys are recognizing these kinds of patterns in your own thinking here. And then I got into the whole, regulatory compliance and GDPR thing, and gee, this is getting harder and harder. And then I and several of my companions discovered this notion of microledgers, and we feel like it was kind of an aha moment for us. So I'll explain what microledgers are, and I think you'll see how that's relevant to this arc when I'm done. But let me just point out that that same kind of arc that I just described in my own thinking we're seeing unfold in lots of different ways in the whole blockchain space. All of the things on this list here are examples of projects where somebody has thought hard about the original blockchain paradigm and tweaked something in an interesting way because of that same arc. And, you know, the tweaks are different. Plasma is about taking smart contracts off the blockchain. Triple signed receipts is about preserving confidence in data but not having to keep a full history even though you have strong proof that you're at the right state. Anyway, they all have different things up there, and if you don't know about all those, I didn't know about all of them either until I went and researched this talk, and I was looking for patterns. I knew about some of them and I found some others there. But the point is that I think the whole industry is going through a maturation phase where we're realizing that there's certain aspects of what blockchain can do that we love, and there's other aspects of what blockchain gives us that we don't love so much, and we're trying to kind of wrestle against those constraints. Now, these are the two things that I think these arcs all have in common, mine and the things on the previous slide. They're all trying to do less with the central big blockchain in some creative way so that they can keep the special value out of the blockchain but not have some of its downsides, right? Okay. So now I want to just point out something. I went and looked, just for fun, I went and looked up architecture diagrams with Google. I was looking for old client-server architecture diagrams. Okay, and these are just 3 that I picked at random out of the Google image search results list. You see that client-server is kind of this old paradigm where we have this notion of a centralized thing, right? And client-server equals bad, right? We've been down that road. We don't like that anymore. But here's what's interesting. I also went and searched for some architecture diagrams about blockchain. Isn't blockchain supposed to be highly decentralized? And lo and behold, there are lots and lots of evidence in these diagrams that blockchain is actually just almost the exact same thing. Now, there's some things about blockchain that are different. I'm not arguing that they're identical. But the point is, there is this phenomenon sometimes that blockchain has been used in a way that's far more centralized than we like to admit. Yes, there are nodes that spread the load around, and yes, the nodes create this notion of diffuse trust, and yet all of those nodes can be treated as one bundle in the middle. And in fact, in a lot of architecture diagrams that you see in presentations at this conference and any other conference, you will see a little graphic that represents the blockchain and a bunch of arrows coming to it from all over the place. And what's that? That's centralization. Okay, so we don't necessarily need the blockchain for everything that we think we need it for. Vitalik, back in April, I'll let you read that quote there. Well, actually, I'm going to read it because it's such a good one. Blockchains are far less efficient computer and database than technologies that have existed for over 40 years. Efficiency is not what blockchains are built for. If you actually go and look up that quote, he does a comparison of how much it costs to do certain kinds of computations on Ethereum versus AWS. And it's about a 1,000,000 to 1 difference in efficiency. And then founder of Liquidity Network in June, this is a really good quote too. Bottom line is this notion, why would you need a mediator if you're actually agreeing with each other? Now, there's an answer to that question, but there's also that question exposes some interesting things to think about. So I think smart people in the industry are starting to question some basic assumptions. And here's my picture of an architecture that's centralized and blockchain oriented. You got the blockchain in the middle here, and you got the arrows coming to it, right? This is how I was thinking about my own particular problem, which was the identity management and relationship management problem that's at the core of identity when I first came into this world. And if you see, we've got 2 parties that each have a relationship and want to trust each other. We have Alice, we have Bob, and Alice needs to know some things about her view of this relationship, and she also needs to know some things about Bob's view of the relationship. Okay? And these 2 views of the world are somewhat symmetrical and complementary, but they're using the blockchain in the middle as the trusted intermediary. And like I said, this view of the world sort of works, but it chafed on me, and it became increasingly uncomfortable as I learned some of the drawbacks and challenges to it. So here's what I evolved to, and this is what I want to talk to you about is the microledger notion. So in this notion, you still have a blockchain, and blockchain does have relevance. It's highly relevant, but it's not used for the main. It's not the main mediator of the relationship between Alice and Bob. Alice and Bob talk to each other directly, and then they have this kind of back channel thing that they can use to interact with the blockchain to the extent that they need to. And I'm going to talk about what they really need the blockchain for, but it's not as much as we thought, at least as much as I thought to begin with. So when you have this kind of a relationship, what you have is two parties that are kind of at the edge of the old diagram. Instead of the thing that's in the middle, you have the things that are at the edges, okay? And these things at the edge are talking to each other, and this is how I get the concept of an edge chain. That's where that word in the title of the presentation comes from, is the notion that you can have some of the same characteristics of a blockchain. You can have high trust and tamper resistance and diffuse patterns of communication and so forth, but you don't have the blockchain sitting in the middle of it. It's all happening out at the edges, okay? So this evolves even further. If you have this person, Alice, having relationships with multiple people, she continues to have these all as kind of lateral or side relationships. She doesn't have them through the blockchain. Now, you might be saying, well, wait a minute, if you take the blockchain and all those big arrows out, what is it even useful for? Well, in my case, it's useful for certain problems that require external trust. So, for example, there has to be a place where I can announce that a credential upon which identity is based has been revoked. And the world needs to test for that condition when they're seeing credentials presented. I know that there's people out here who aren't in the identity space. I think there's analogs to this in non-identity world too. There's certain things that you need to consult the blockchain for. But the main things that aren't on this list are things like talking to each other, storing things, doing computation, interacting. None of that stuff has to go through smart contracts or any of that. It just has to have a few very small things that make this possible. So besides revoking credentials in the identity space, you have to be able to revoke a device. If you leave your phone on the back seat of an Uber, you need to be able to quickly say, don't let anybody use that phone to impersonate me. You need to be able to discover parties that are intending to be public. You need a secret rendezvous spot. So if you think of secret agents that, they're heading off into enemy territory and they agree that if they're not back by such and such a time, then they're going to meet in the square at midnight or whatever. Well, you can use a blockchain kind of like that, as we'll agree that we'll rendezvous on the blockchain if we lose track of one another or have to repair a relationship and we can't do it by direct conversation. And it turns out that Merkle proofs of state integrity between these two parties can be relevant. Now, this last one is where I get the name Microledger for this talk, and that is basically the way that these two parties interact with each other has to have some characteristics of provability and tamper evidence, even though it's not on the main blockchain. And you can do that by doing some very simple, well, it's not very simple. It's simple compared to other stuff, crypto, and so forth on your local hard drive, and when you interact with the other person, passing them Merkle proof of state, having them check it against what they have, you end up knowing with confidence that both of you have the same thing and you haven't drifted or misinterpreted one another. So you end up basically having a tiny little ledger on your machine for the relationship. Alice would have one for the relationship she has with Bob. I'm talking tiny. I'm talking 5K, 10K, little tiny files. They're not massive. They don't last necessarily forever. They don't store any significant amounts of information, but they just have an orderly sequence of hashes that show how state has evolved. That's the microledger concept. So after we started playing with this idea, I started to see things a little bit different. This is my journey again, but I saw it, instead of it being kind of a time sequence, I saw it as a continuum of centralization. And I really think that's where my mental journey took me, is I started out thinking blockchain was cool and I'm going to be decentralized, but I wasn't really very decentralized in my thinking. It took me a long time to get there. I started kind of over with put it all on the blockchain, which isn't so far away from traditional client server. Okay? Then you start seeing people talking about subchains and side chains and things like that. That's an example of moving farther to the right on the continuum. And then you hear people talking about, well, just anchor it on the blockchain. Now we're starting to get pretty far over towards the right. If you go all the way over to the right, you have a pure edge chain, where you really don't need the blockchain at all. Now, I don't think I'm going to write any software that lives completely at that end of the continuum. I think blockchain introduces some characteristics of trust that I really need. But I think I can get pretty far over here, get all the benefits from blockchain that I really care about, but not have hardly any of the drawbacks or complications. And the only price is complexity. Darn it. Okay, so I put up here on this picture also, I have dApps right here and edge chain protocols. When I first started exploring this notion of the edge chain, I was calling the thing that we were building a dApp because it's a decentralized app, of course. But I realized that what the industry is calling a dApp is actually pretty far over to this side, because it's typically running everything through a smart contract that does centralized computation. And there are dApps that aren't that way. So the dApp thing moves over towards the right. There are some dApps that get maybe almost this far. But you can take it all the way over here, and I think if you go way over to the right side, it's not really fair to call that a dApp, because it's pretty different from what the industry thinks a dApp is. And I'm going to give you some examples here in just a minute. So just for kicks, I'm going to introduce a new word to you, because this is why I'm excited about the right end of that continuum. I think that the things on the right end of that continuum have this characteristic. This is a big word, a $24 word, but teleemergent. So if you're familiar with the word teleology or teleonomy, this has the notion that you have order from chaos, okay? But it's not order that's decreed by some central party. It's order that arises spontaneously. Teleonomy is used in discussions about evolution and biology, and how a very complex ecosystem can manifest really sophisticated patterns of behavior, even though there's not anybody out there telling the zebras which direction to run when the lions chase them. And so you may have also heard the word chaotic before, and you may have run into the notion of Adam Smith's invisible hand in the economy. It's the notion that you give a bunch of independent actors the right incentives, and lo and behold, the free market causes an interesting dynamic to emerge that's useful. And that's what I think is the true characteristic at the far right side, is that you give independent agents the ability to interact, and these agents find useful ways to interact according to a protocol. So this is just a little compare and contrast. I think I'm going to skip over this. Suffice it to say that dApps and edge chains have a lot in common, but I think there's some interesting differences. And maybe during Q&A we can come back to this slide if you have questions about it. But let me now actually give you some examples of what I'm talking about. When you define an edge chain protocol, you have to answer these 4 questions. What are the roles in my protocol? What types of messages do we exchange? What state or sequencing rules apply? And how are trust and incentives managed? So here's a really familiar example, okay? No tech involved. How do you buy a house? Okay? What are the roles in buying a house? Well, you have a buyer and a seller, and the realtor for the buyer and the realtor for the seller. You have a home inspector, you have a title company. These are roles. And by the way, buying a house is a protocol, right? You can't just go order a title insurance on some arbitrary home, because that would be out of order. It's not the sequence that you have to start by doing step 1, and then you go to step 2, and then you go to step 3, right? And the parties in this interaction have responsibilities. They can do certain things and not other things, okay? So the kinds of messages that get exchanged in this protocol, well, we have an offer to buy, a counteroffer, an acceptance, a rejection, a home report, a title search. These are messages, okay? What are the state rules that apply? Well, this is an example state machine I drew. You start by negotiating, and you can go round and round in circles negotiating. Eventually, you exit the negotiating phase, and you're in the preparing phase where you order a title search and a home report and all these things. And anyway, you end up consummating the deal or not consummating it. But that is an edge protocol. Why is it an edge protocol? There's no blockchain involved, right? It's people out at the edge. But there's 100,000 things like this. Ordering a hamburger is a protocol. Right? You can't just walk up to somebody and say, here's $7.25. You have to walk up to them and say, I want number 3 on the menu, then give them $7.25 after they ask you whether you want it to be, is that to go or not to go, right? There's this whole protocol involved in that we all know. So the reason I'm harping on this is because all kinds of business problems are solved by protocols all the time. And in fact, they're mostly edge protocols. And that's a cool thing. If you can just hook them up to blockchain for just the parts that you need them for and not all of it, the weight of what you're building goes way down. So here's a simple edge protocol that's techie. This one is one that's relevant to the identity space. This is the trust ping protocol, and in Indy there is a hype, which is like an RFC, about how you ping another person. You have their DID for them. That's their identity, their identifier, excuse me. And given that identifier, you should be able to reach out and talk to that person. So how do you do it? And according to the whole Indy technology, you should be able to do it no matter what transport you're used to send messages, whether it's HTTP or mail or Bluetooth or whatever. And you should know some things when you engage in this trust ping about whether the person on the other side is trustworthy and how much trust might have been eroded by the kind of mechanisms you used in between you and stuff like that. So there's a hype about that. You can see the roles, the ping-er and the ping-e, and the message types. Let me give you a quick demo of this protocol. What I have here, I'm going to start up an Indy agent. And that agent is going to be listening on email, and I'm going to talk to it by email, and I'm going to use the trust ping protocol to interact with it. So this is the, let's see, is this the, yeah, this is the trust ping protocol documentation. And the trust ping documentation says that if I want to ping somebody, this is the kind of JSON message I need to send it. So I'm going to send it one. Let's go over here to my email, and I'll bring up my little trust ping. Nothing up my sleeve. Here's the JSON that I'm sending, which is just a direct copy and paste out of this hype here. So that's the stuff that I sent. And let's see. Message was sent. That's good. Now what we got to see is if the message is going to come back. There we go. So the agent on the other side pinged me back. And let's see what it sent me. It sent me an AIM-style message, except it's not fully encrypted right now. I turned off the encryption. This is the JSON that I got back. It says, "Hi from Indy Agent." So I've just engaged in a protocol here. Now, what does blockchain add to this? I could do this entirely without blockchain, but there's some things I wouldn't have. I wouldn't have confidence in the other sender. Somebody could sit in between me in this protocol and mess with my mind, right? Be a man in the middle. So most of the protocol is not modified, but by adding a little bit of blockchain pixie dust, I'll call it, I can increase the trust behind this protocol. And that's the kind of thing that I'm seeing over and over again as I get my head wrapped around this paradigm. Is you start with a paradigm that's really not very blockchain heavy, and then you say, okay, what are the things that's wonderful about blockchain that I need to add into this, and how can I do it as light as possible? Okay, so on to the next thing here. Tic-tac-toe. We could also play tic-tac-toe. I'm going to wait and see if I have enough time. I'll do a demo of tic-tac-toe if you feel like it later. But anyway, I have a demo of that if you want to. This one was not, there's no blockchain goodness on this. This is all the way to the complete right side as being a pure edge protocol, because you don't need a blockchain to play tic-tac-toe. Okay, this is a more serious one. What if you want to manage a relationship? So Alice and Bob live across the world. They use complicated technologies. Each of them has different technologies. One of them has a laptop and a cell phone, and the other one has a desktop computer at work and 2 cell phones and something in the cloud, and they want to talk to each other, and there's different pieces of software running on all these different things at different version levels and all this kind of stuff. How does Alice tell Bob, hey, you shouldn't accept any messages anymore from my old cell phone that I just sent to the recycling? I think they told me they were going to wipe the hard drive on it, but I just don't trust I'm going to tell Bob not to do that. You know, how does Alice say, hey, I upgraded my own world here and I've got a new device, and now if I send messages from that device, you should trust them? How does Alice say, I'm going to rotate my keys? All of these are concerns of managing a relationship, and you need a protocol to manage a relationship. And guess what? It's mostly an edge protocol. So this is a more serious one that has pretty high stakes, and I've been working on a method to describe how DIDs can be created and the DID docs associated with those DIDs can be shared. And you can see the roles here, the participants in the relationship, and there's some message types that are described here. There's actually a DID method spec draft, and I'll show that to you really briefly here. And you can go look it up yourself later if you want. I'll give you the URL and you can go read it. But anyway, there's this whole spec behind this. And so this one is the thing that has caused, I think, the most ruminating on the concept of a microledger, because the microledger as a persistence mechanism could provide high trust to back the DID method that I'm mentioning here. Let me go on to another one that's maybe a little bit more interesting. So this is just an imaginary one, but I think I'd love, if somebody in the audience wants to build this, I'd be super excited and I would buy your app. A megaphone protocol. What I'd like is something where if I'm sitting on the beach in Indonesia and a tsunami happens, I can grab my phone and push a button and say, run, a tsunami's coming, and my phone contacts all the phones all around the resort where I'm staying, which in turn contact all the phones a mile inland, and everybody starts running, not just the people who can see the wave. Wouldn't that be cool? I want basically a virtual megaphone. But why do I need blockchain? There's a really good answer to this. I can't build this right now because if everybody had a real megaphone in real life, you'd have problems with people using it irresponsibly, wouldn't you? So there's a trust problem. I can use blockchain to require people to put stake or put their identity in escrow against their responsible behavior, so that a person can say, look, when it's a life or death situation, I need an EpiPen right now. I'm willing to, have $100 on the line, or I'm willing to have my identity disclosed if I am shown to use that irresponsibly. And that protocol can hook back to the blockchain as a basis for that trust. But most of everything that's happening is all out on the edge. Okay? And you can see some of the other ones. My child is lost at Disneyland, or I'm desperate to get on this plane. Is somebody in this line willing to sell me their plane ticket for 1,000 euros? Any of these kinds of things could be done with this kind of a protocol, and you would just need peer-to-peer communication in your app, or you could have the app go back to the cloud and talk to other apps through the cloud if you needed to. That would be more centralized. But anyway, there's some roles in this: a speaker, a listener, and a relay. So you could have an app, and a person could talk through your app to another phone that was close to you, and so the word would spread, right? If anybody's interested, there's a link to the concept doc when you download the slides. You can go read more about that protocol. So here's my suggestion to you. I hope that I haven't gone too deep. I've tried to stay really high level. And I hope that I've been general enough that even if you're not in the Indy space, the identity space, you're thinking a little bit to yourself, yeah, maybe there's some ways that I'm taking for granted that we need to use the blockchain for something, and maybe I shouldn't. Maybe I should think from the other direction instead, start thinking about the problem as an edge protocol problem, and then say, how do I sprinkle the magic pixie dust of blockchain just enough to get the properties of trust or the constraints that I need? And what I've found is that this is a very liberating experience. 2.5 years in, a lot of the problems that I initially thought were really yucky, I'm now thinking, well, if I flip it on its head, I can get what I need to, and I don't have the performance problem, or I don't have the scaling problem, or I don't have the centralization and trust problem, or the regulatory problem. So I want to encourage you to do that. Think in terms of the edge with a blockchain as a useful foundation that you can refer to, but not necessarily as the place where it all happens. You don't have to compute everything in a smart contract, and you don't have to. And if you say, well, I don't know how to do that, there are some problems that you must use blockchain for. But I'm just saying, use it wisely and not just peanut butter spread it on everything. And then I would love to get some people here to work with me on this peer did method. I think it's a very high value for the identity space. That's one that's specific to my area of expertise. So with that, I'll go back and demo something if you want, or we can go into Q&A. I think we got about 10 minutes left, which is good. I was trying hard to not go till the very last second.
When you talk about being an edge protocol, does that imply there's a person on the edge that the interaction is with?
Well, it doesn't necessarily have to be a person, but some entity on the edge. Yeah, and I'm really using, the term edge, of course, is really vague. But what I mean by it mostly is it's not the thing in the center of the architecture diagram.
Okay, and then the second question, the concept of the microledger, is there any concept of persisting the final values of the microledger onto a blockchain?
Yeah, so this is, if I go back to, let's see, the notion of anchoring something on a blockchain, a number of people in industry are exploring different ways to do that, and one of the things you could anchor on a blockchain is a microledger. So if you needed to prove, for example, to a third party, let's say Alice and Bob are interacting, and it's a private personal relationship, but let's say Bob doesn't fully trust Alice, and maybe he's afraid that Alice is going to steal all of his cool music for his next album, because he's been sharing it with her. So he goes and he anchors some things on the blockchain to provide evidence so that if anybody ever, if there's ever an argument, there's a third party that's a witness, that kind of a thing. And there's other kinds of use cases like that too.
Hi. So obviously it's a communication protocol, so I was wondering if there was any thoughts about communication recording, or if it could be useful in any way. I know there have been papers for TLS communication recording, but obviously it's not easy to do at this point with TLS and HTTPS. So is there any ideas about communication recording between the agents or DADs and how it could be possibly useful?
So that's an interesting question. I used to work at Blue Coat, which makes a line of products. Actually, Blue Coat's been acquired by Symantec, so if you look this up now online, you're going to have to look under Symantec. But anyway, Blue Coat made a product called an Ssl Visibility Appliance. And what it is a deliberately constructed man-in-the-middle attack on a TLS session. So an enterprise does some fancy magic with certificates to make it so that when you inside the enterprise talk to somebody outside the enterprise, that appliance catches the traffic and it man in the middle's both of you. Neither side can tell that there's this thing in the middle. And the whole point of it is make the TLS channel visible so that the enterprise can look for malware that's coming into the environment and stuff like that. So where I'm going with this is that same kind of technique could be used in agent-to-agent communication. However, you would have to get the consent of both ends of the conversation. You don't have the ability, like you do in an enterprise, to simply say, well, every browser in our enterprise is going to accept this certificate authority, therefore nobody's going to get any warnings when they click and stuff like that. So self-sovereign identity technologies provide a protection against that kind of sniffing happening invisibly. But it could be done. And the other thing I was going to say is there's also a proposal about message tracing. This is cooperative, voluntary message tracing where people are trying to troubleshoot a complex interaction. And they say, hey, please tell me when you get this message and forward it on so that I can see what's happening. Parties don't have to follow it, but it's somewhat related to recording. So I guess I can only think of those two comments about the recording concept. Maybe we can talk some more after.
Danny, I actually have a follow-up question on what happened here. So I'm sure you're familiar with Signal. Mm-hmm. In Signal, they're using double ratchet and then triple defilement, and they create that end-to-end encryption. Mm-hmm. So how does this really different when it comes to peer-to-peer and then just creating that encryption? Because you just mentioned that if you're going to man-in-the-middle attack, and I'm quite familiar with what Blue Coat does. I work at Symantec as well. So you have access to the private key. You are able to record a session, and then you're able to replay it. So basically acting as a proxy. So how does this not apply in this scenario? Because if I'm able to actually sit in between, let's say I hold a network, and then I compromise one of the parties, then this is basically just a broken channel.
Well, first of all, Indy communication, this has not been implemented, but the hype has been accepted, is adopting Signal's double ratchet algorithm. So forward secrecy and so forth is a property of the communication channel, the same way it would be with Signal. The DID method spec that I talked about here, one of the key characteristics that it has is that when you create a DID, you must create it by deriving it from the public key of a key pair that exists. And the reason that that requirement exists is because you don't want, well, let me take you down a different path. If you started a DID as just like, let's say, some UUID, and then later you associated it with keys, what could happen is you could start it, and a person who's proactive and malicious could notice what your DID is, but you haven't asserted keys, and jump in and create the kind of man-in-the-middle situation that we're really worried about here. But because DIDs require you to derive the thing from the key, the DID value from the key, there is no point in time where the creator of the DID is vulnerable to the man-in-the-middle attack. That's only a partial answer to your question. Let's talk about it after. Yeah.
I had yet another follow-up on this thread. So the IETF has an existing internet standard called the Host Identity Protocol, and it does exactly the same thing. The intention there is because right now in networks there's the IP address as the identity, but this is not verifiable. Mm-hmm. So they made this protocol with the intention that it existed to be compatible with the internet's TCP/IP stack. Mm-hmm. So there is no tie to an Ethereum network or a Hyperledger implementation. It's just part of the general internet. Can you give me some context as to why this is existing separate from that and we don't just use the host identity protocol existing on the internet already? So that's a great question. There's several different answers that are all kind of related that kind of add up. The first thing is that this communication mechanism has to work on things besides the internet.
Not everything has IP addresses, and still we have to be able to communicate. We certainly live in a highly IP-centric world, but there's plenty of use cases that are outside that. The second thing is that, like with certificates, my understanding of the host identity technology is that it focuses on servers. Now, of course, it could be used for clients and stuff too, but TLS in general, even though it has the option of identifying both parties, is almost 100% used to identify only the server side of an interaction. So when you want to identify the client side, what do? You have this great channel, but you don't use certificates. You have an entirely different mechanism, which is browser-based sessions and cookies and all this other stuff to identify the other party. You log in, you present some credentials. And I think the same kind of phenomenon maybe is undermining some of the value of that protocol, where it's going to be applied, whether the protocol's written that way or not, it's going to be applied just to identify things that have a permanent presence. Does it work for mobile phones that are changing IP addresses constantly and that are refreshing their software and all that other stuff? I don't know enough to know. Maybe we can you share a link with me or something and I'll go learn some more about it?
This seems a little bit familiar with the theory of state channels.
State channels are on my list of, you're right here. Whoop. State channels.
Oh, okay.
Yeah, the state channels are an example of this kind of thinking. Yeah.
Thanks. I have one question concerning the edge chain protocols. As I understood you, you suggested we make small protocols and different apps. But what when I want to glue them together, because they together build a higher level protocol? Would I then try to make the glue in the blockchain, so things that those protocols need, store it there, or would I define, let's say, a super edge chain protocol? So.
Well, yeah, protocols are one of those things that can be understood at. There's lower level ones and higher level ones, just like there's the OSI stack and so forth in networking. And you can combine logical entities into bigger constructs to make higher level protocols. Something that you said kind of gets at this slide that I skipped over. One of the things that's different between dApps and edge chain protocols is that edge chain protocols, there's no set of apps that you have to have. You just need to have software that is capable of playing all of the roles in your protocol. And it could be written by 10 different people, and there could be 10 different providers of one of the roles if you wanted, right? So think about like buying a house. We don't have only one place that you go to get all the actors in the buy a house protocol, and yet dApps are typically written where you write a dApp that implements the whole thing. And so that's a little bit of a paradigm shift.
Is it something also kind of microservices?
Yeah. 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 Doesn't have to be implemented on servers, so it's not exactly microservices, but it's like that in the sense that it's a bunch of little granular things.
Hi, thanks. This was really interesting. I was going to offer a bit of nitpicking for the megaphone protocol. I think if you don't take in consideration economic pressure, I think the protocol will probably fall apart, because some people will be in such situations that they'll be willing to trade what they consider their unimportant identity to spam people nearby, and there'll be markets that will probably show up saying, hey, if you do this for us, we'll give you some money, and people might burn through their identity because they don't see the value of it, or maybe they will try and stack up multiple identities as much as they can. Obviously, we would expect the system, the overall underlying self-sovereign identity system, not to allow that. But I think if you don't factor in economic pressures, especially for those of us who are very poor, you won't be able to expect some of the ways that the protocol will be manipulated.
That's a good comment. The concept document includes the notion that megaphones have a volume, and you can select the volume. If you say, look, I'm tired and hungry, and I'm a mom in an airport, and I have a baby, and I need to change the baby's diaper, and I forgot a diaper, that's not a life-threatening crisis, so you don't need life-threatening volume. And so there's probably different staking for different levels of volume. But I think there's still, you're right that there's potential for abuse, which is maybe one of the reasons that nobody's been working on it yet. Okay, well, I think we should declare the session over, and I'll be up here if anybody wants to ask more questions. A couple of you asked me questions that I want to get some more information about. If you'd just come and talk to me, that'd be great. And thanks for your attention. I appreciate it.